Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so question 2 says the graph below shows the relationship between the boiling points of the hydrides of the group 16 elements and their molecular mass, right? Then 2.1 says define the term boiling point. So quickly on that one, we say a boiling point is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. Right. And that's how we define it. The temperature at which the vapor pressure of a substance is equal to the atmospheric pressure is known as the boiling point. Right. Then let's proceed. 4.2 says consider the group 16 compounds excluding H2W. State the relationship between the molecular mass and the boiling points of the compounds. So they're saying excluding this one here. So that means we are looking at the relationship from H2X, H2Y, and H2Z. Now, one thing that I want you to note is that the X, Y, Z, and W here, these are not compounds. These are just, this here are not elements, meant to say these are just unknowns, right? So all of this element, all of this compounds here, or all of these elements, W, X, Y, Z, they are in group 16. That means it can either be your oxygen, it can be your sulfur, it can be any of those there, right? But then the W, X, Y, Z does not represent actual elements. These are just unknowns. So we are just using them to represent the unknown elements there, right? So do not go ahead and be looking for this in your periodic table. There is no W, X, Y, and Z in your periodic table there. Right. So, okay. 2.2.1 says state the relationship between the molecular mass and the boiling points of the compound. So this one here. Now, what can we observe from this? We can observe that as the molecular mass increases, what is happening to the boiling point? The boiling point is also increasing. So that is the relationship that we say the boiling points increases, or the boiling points increase with an increase in the molecular mass. So that's it. That's the relationship between the boiling point and the molecular mass. There is that the boiling points increase with an increase in molecular mass. So that's all you are supposed to say. Then 2.2.2, explain this trend at boiling points, refer to molecular mass, refer to the intermolecular forces and the NH. So again here, looking at this 3 here, how do we then explain this? Remember, we cannot really comment much on the type of intermolecular forces that are there, since we don't know the elements that are there, right? So we're just going to say, as the molecular mass increases, so we're just going to explain this based on what we observe from the graph. As the molecular mass increases, we say, the strength of the intermolecular forces increases as well. The strength of the intermolecular forces increases. right? And then that means more energy is needed to overcome the intermolecular forces. The intermolecular forces of larger molecules. Thus, the trend that we observe is that the boiling point increases. So thus the boiling point increases. Thus the boiling point increases. Okay, so as the molecular mass increases, the strength of the intermolecular forces increases as well. More energy is needed to overcome the intermolecular forces of larger molecules. Thus, the boiling point increases as the molecular mass increases. So that's how we have explained the trend. Okay, so in 2.3.1, 2.3 is saying H2W does not follow the trend at boiling point for the group 16 elements. As we can see, it is an outlier there. It is the only one with a very high boiling point there, and then which is not following the trend of these three other compounds here. Okay, so now 2.3.1 is saying identify the compound H2W. Now, how are we going to be able to identify that? We can just go ahead and just directly link this to the molecular mass here, and then we can see that the molecular mass of the H2W compound is 18. Right. Now, the only thing that is stopping us from knowing this compound fully is this W here, which is an unknown, right? So we can fully know this element if we can know the molecular mass of the W, and therefore we can be able to identify it from the periodic table in group number 16. So what we are going to say is that the H2W must give us 18 grams per mole, but then now we know that the hydrogen is only 1. The molar mass of hydrogen is 1, so we have 2 atoms of hydrogen, or 2 atoms of hydrogen, which means it's 2 times 1 plus the W there, which is equals to 18. Now, if we want the W, we're going to say 18 minus 2, which will end up giving us 16 grams per mole. Now, from our group 16, let's check and see which element here has a molar mass of 16. And then we can see it there, it's oxygen. So oxygen is equals to 16 grams per mole, meaning that the whole compound here is supposed to be H2W. If the W is oxygen, that means in the place of W, we just replace with oxygen, then therefore our compound is H2O. So that's how you were supposed to figure that out, just by using the molecular mass here, right? So kind of smart. Then 2.3.2, it says name the intermolecular forces present in this compound. Now, what are the intermolecular forces present in H2O? We already know the hydrogen is bonded to an oxygen, so this has to be what? Hydrogen bond. So for 2.3.2, our solution should be hydrogen bonds, right? So note that the calculation and identifying this was 2.3.1. Okay. Now, 2.3.3 says explain why the boiling point is higher than expected. Why is the boiling point higher than expected? Now, since we have identified that this is H2O, and then we know that this one, the oxygen, is now out of the picture. So that means if we have to say all of this, obviously now we can be able to tell that looking at this 34, this must be H2S, and then must be followed by all of this here, up until we get to the one that is 130 molecular mass. So looking at your periodic table now, it is easy to identify which is which here, right? But then looking at all these compounds that we are going to form here, even for this one example, we can see that now that we will be able to identify those compounds, we can tell that this one here has what we call dipole-dipole forces, where else this one here has what we call the hydrogen bonds, right? As we have identified in 2.3.2. Now explain why the boiling point is higher than expected. This is how we will explain it. We will say the hydrogen bonds in H2O are stronger than the dipole-dipole forces, which are in the rest of those compounds, are stronger than the dipole-dipole forces. Now, obviously, more energy will be needed. More energy will be needed to overcome the hydrogen bonds in H2O, right? So if more energy is needed to overcome the hydrogen bonds in H2O, this means thus H2O has a higher boiling point. So this is the reason why we have our H2O having a higher boiling point. Why? Because more energy will be needed to overcome its intermolecular forces. So this will tell us that it has a higher boiling point because of the relationship intermolecular forces directly proportional to the boiling point. So the stronger the intermolecular forces, the higher the boiling point. That's how you were supposed to tackle this question, all for a total of 12 marks. So please note how I went about answering this question. And then with all that being said, guys, please press that thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.